what happens if in the atria there gets to be, for whatever reason, we'll discuss reasons, but for whatever reason, let's say that something in the atria happens where a signal is coming down a pathway and it gets to the AV node and it does what it's supposed to do to the AV node, okay? But at the same time, something caused a block in one of the pathways somehow, whatever that is. But it was just a temporary block. It was just a momentary block. And so the signal didn't complete that particular pathway. And the AV node got the signal, and it sent the signal down the bundle of His, but it also sent it back up that pathway again. And so one pathway was depolarized, and another pathway was being depolarized from the AV node. Does that make sense? And then as that happened, that pathway depolarized the other pathway again. And now we have this situation where we have kind of this circular pattern of depolarization in the AV node, in the atria itself. Where it's just constantly depolarizing itself over and over and over again. How might that look?
Is that going to be its own little tachycardia?
Well, I don't know. Is it?
Well, I said it, so yeah. I think so.
Yeah.
How would it look?
I think so.
P waves that are happening on a consistent, fast basis,
Okay, P waves that are happening on a consistent basis.
and they're usually faster than the normal. And then every so often you get a QRS when the AV node is out of its refractory and it catches one and fires.
Okay, did you hear that?
Yeah, but I didn't get it.
But it doesn't say.
So because of that loop, you're gonna have regular P waves happening, and every so often when the AV node is out of its refractory period, you're gonna have a QRS that lands, and it's gonna go back into the loop, and every so often another QRS will happen when it's out of its refractory.
Did I hear that?
So there'd be more people.
So you'd have what they call sawtooth P waves, and then occasionally a QRS.
Oh, so it won't necessarily be.
And that P wave would be on top of the T, or in the T, so would the T look
Okay.
different?
So what you end up getting is in the atria, you never have a baseline. In the atria, you never have a baseline. That means every time it comes back down to baseline, it immediately goes back up. There's never a period of baseline anywhere. Right? We should have a period of baseline. We should have a PR segment at some point. But there isn't one. And as that's happening, the AV node is still getting signals, right? And as it gets the signal, it will fire after it's gone through its refractory period. Good? What ends up often happening is the AV node will start to get into a pattern of which signals it responds to. And it'll be the same pattern almost always. Sometimes it's not, but it's often the same pattern every time. So maybe every fourth time the atria cycles that circular pattern, the AV node catches it and sends it. And then it waits for 4 more, and then it catches it and sends it. Good? So in this situation, we would see atrial activity that's happening clearly, but there is no baseline to it whatsoever. Every time it comes back to baseline, it's immediately leaving again. So there's never a baseline to it. If I have a lot of atrial activity without a baseline to it, then I would say that I've got this circular pattern happening, and it's something that we call atrial flutter.
So you're saying
And
that
these waves are called F waves with a capital F.
So you say normally you'll have a pattern like it'll catch on every fourth. Can you have it catches on 2, 3, 4, and then like 2, 3, 4,
Yes.
and then 2, 3, 4, so you can have a pattern of
I can have a larger
a
pattern.
segment of 3 QRS.
Yeah, it's not common for that to happen. It's more common that it catches either on an exact pattern or an arbitrary pattern.
Okay.
We call it either, we name the conduction, which I'll describe for you in just a moment, or we say it's variable. It's just all over the place.
Why is it called an F wave?
Because it's a flutter wave.
Yeah, but that's a P wave.
No, it's not a P wave because in this case, we are seeing that circular pattern, and we have a similar result to the AFib in that the atria can't really contract altogether very well because it's getting that signal so quickly that we have some contraction but not others, and we don't have a clean contraction of the atria. Very similar to what we have with AFib. In fact, we put these two together most of the time, AFib and A-flutter. Because we're not getting a clean contraction. We will have gotten it the first time, but after that starts to cycle like that,
But why wouldn't that be called an F complex?
why would
Because
we
you're
call it?
naming it off the aggregate of these signals.
I didn't name them. I'm just telling you what their name is. You could go through and say, I want us to name this differently because it doesn't make sense to me, but I can't do that. It is. We're saying it is an aggregate of those different things, but each one we're just calling a large F wave. And we're doing that to distinguish it from flutter, and we're doing it to distinguish from normal P waves. Yes, this is atrial activity, so yes, it is P activity, but because it's not a clean P wave by itself, that goes back to baseline.
Are your T waves suddenly F waves as well?
No. So, here's, because the T wave is what? What does the T wave represent? Yeah, ventricular repolarization. Yes, you will have these flutter waves tied into your T wave, and it hides your T wave. Your T wave's hidden, but it's not, doesn't cause your T wave, it doesn't have anything to do with your T wave, other than that it's happening at the same time. You will also see it tucked into your QS complex. So I have an F wave right here as well. And an F wave right here. And an F wave right here. There are F waves tucked into those QRSs as well because they never stop. They don't ever stop. So,
Would you typically see,
so I would call this, when you look at this, even though you only see 3 flutter waves and a QRS complex, this is actually a 4-to-1 conduction. I have 4 flutter waves, 1, 2, 3, 4, to my QRS complex. And actually it's the other way around. It's 1, 2, 3, 4 with a QRS. 1, 2, 3, 4 with a QRS.
yet all the QRSs would still look relatively similar because
Yeah.
they're all being morphed equally because of the flutter wave?
Correct.
Well, because the AV node.
Correct. That's correct.
And then the T wave, quote unquote, would still look similar because they're all being affected the same.
Correct. It's just very hard to see the T wave at all because of the flutter that's happening on
The
the
flutter overpowers.
Yeah, so
the-
it's difficult, but you will see this set of waves with the T wave involved will look a little bit different than what it looks like here and here, but it'll look similar to what it looks like there and what it looks like there. You'll clearly be able to see that there was T activity, but it'll be hidden. It'll be very difficult to tell.
That was gonna be my question, was just a recap of where the T was and what it was gonna look like, but
Yeah.
you answered it.
Will the rate be based off of just the refractory of the AV node?
Yes. Yep. Yeah, so my heart rate will be based off my QRS complexes, because that's what's perfusing. So that's what I'll take as my heart rate. But do realize that this is the first time, well, it's not quite the first time, but it's one of the first times that we're really gonna start maybe separating what's happening with the atria and the ventricles. Because my atria has a rate that's very different than my ventricles. My atria has a rate that's close to 300. Because I'll see one of these flutter waves every big box on the EKG. So the atria is pumping along at close to 300. My ventricles are pumping along at something less than that. Good? In fact, a very common A flutter is to get an A flutter with a 2-to-1 conduction. A 2-to-1 conduction. If if I had a 2-to-1 conduction and my atrial were firing at 300, what would my ventricles be firing at? 150. That's right. So I might have a 2-to-1 conduction, I might have a 3-to-1 conduction, I might have a 4-to-1 conduction, or I might have a variable conduction. When I say the word conduction, what it means is that I have, if I say I have a 3-to-1 conduction, I'm saying I have 3 of something that then conducts to 1 of something else. And the conduction is what's going through the AV node. Anytime you hear that word conduction, think what's going through the AV node.
So this is,
So a 3-to-1 conduction would be 3 flutter waves for every single 1 QRS. And in this case, what I've drawn up here is a 4-to-1 conduction.
so this is an A flutter with a 4-to-1 connection with atrial rate of 300 is a visual rate of 75.
Yes,
Why 4-to-1 and not 3-to-1? Because that
because there's one right there,
one buried in the conduction.
and I have to count it.
You have to count.
So I have 1, 2, 3, 4, and a QRS. 1, 2, 3, 4, and a QRS,
Okay.
right? You can't forget the one that's hidden in the QRS complex, because there's never a baseline for what's going on in the atria. And now the atria are completely independent of what's going on in the AV duct.
What will we see in our patients?
What will you see?
So, well, it would.
What's that?
Possibly nothing outward presentation?
It could be if they deal with this on a normal basis, just like with AFib, maybe you don't see much.
Is it similar to where people have like episodes of AFib, they have episodes of A-flutter?
Yeah, and we actually refer to these things commonly together, and our treatments for them are very, very similar as well. Right, what's our main non-electrical treatment for AFib?
Cortisone.
That's good.
And guess what our main non-electrical treatment for AFib is?
Cortisone.
Is there, just to go
Right
back to
away,
AFib,
no.
is there a baseline in AFib? Attainable baseline
No.
for AFib as well?
No. Yeah, because you've got the AFib all the way
Yeah.
through, so once again, you have very certain what the baseline is. Now, you can still use your ruler and kind of see
Average?
where the QRS is coming down to help you identify ST elevations and such, but it would be very difficult for you to find an exact baseline on either of these. Does this make sense so far?
Mm-hmm.
Questions? Okay, stew about that for a little while, and then tomorrow we'll take that a little bit further, and I'll show you some examples.